This webcast looks at Worksheet 2D, where we're beginning to talk about velocity versus time graphs. So in this webcast, we'll talk about how to create velocity versus time graphs that correspond to situations that we either know from having a motion map or that we know from having a position versus time graph. Okay, so first we'll look at situations where we have a motion map first, and then we'll create a velocity versus time graph. So in number one, we're talking about an object that's moving in the positive direction at a constant speed. Now they don't tell me the speed, and so I'm just going to assume that the object moves at 1 meter per second. So I'm showing a simple motion map. The velocity vectors point to the right because it's moving in the positive direction. They're all the same length, and they are showing a velocity of 1 meter per second. As each second passes, this object moves 1 meter to the right. And I'm showing 4 seconds worth of data, right? I have 5 dots, but the first dot is showing me time 0. Okay, so I'm going to make a velocity versus time graph, and I need to put a scale with some numbers for the time axis and also for the velocity axis. So this is 1 meter per second. So this object is moving at a constant velocity of 1 meter per second. That literally means as each second passes, it moves 1 meter. And it does that for 4 seconds. So I'm showing the velocity versus time graph is a horizontal line that at 1 meter per second, and it goes from time 0 to time 4. So this is important. When the velocity is constant, the velocity versus time graph is shaped like a horizontal line. Let's look at the next example. Here we want to talk about an object that's standing still. So, maybe I'll just put it at 2 meters at that position. So it's there at time 0, it's still there at time 1 second, it's still there at time 2, it's still there at time 3, it's still there at time 4. The dots stack up on a motion map when the object is not moving. So for the velocity versus time, if the object is not moving, the velocity is 0 meters per second. And so, let's see, I want to get a little bit heavier pen here. So the velocity is 0 for those 4 seconds. Okay, let's look at the next example. Here we have an object that's moving in the negative direction at a constant speed for 3 seconds, and then it stands still for 3 seconds. So maybe I'll have it begin at position 5, and it moves in the negative direction for 3 seconds. So my velocity vectors are now pointing to the left because it's moving in the negative direction. And then once it reaches position 2, it stays there for 3 seconds. Okay, now my motion map is showing a total of 6 seconds worth of data. And for the first 3 seconds, let's see here if I can get a pen to highlight that a little bit. In this period right here, the velocity is negative. Remember how velocity is a vector, and the sign of the velocity has to match the direction of motion? Well, this velocity is a -1 meter per second because the object was moving in the negative direction. It did that for 3 seconds, and then for the next 3 seconds, the velocity is 0. Notice that there is a gap. In the first 3 seconds, the velocity was -1, and then my graph jumps up to a value of 0 meters per second for the next 3 seconds. That is okay in a velocity versus time graph. You don't have to have a continuous graph. Having a gap between the values of velocity is okay. But notice, and let's just emphasize this again, when the object is moving in the negative direction, the velocity has to be negative. And so always pay attention to what the sign is of the velocity on the velocity versus time graph, because the sign is identifying the direction that the object is moving. Okay, in example 4, we're looking at an object that moves in the positive direction at a steady speed for 3 seconds, and then it reverses direction and moves back in the negative direction at the same speed. Look here, it reverses direction, but it does not pause. They're not telling me that it waits for a second. Since it does not pause, so here is the motion going in the positive direction for 3 seconds. Since it doesn't pause, there are no dots that stack up here at 6 seconds. After 6 seconds, it immediately turns around and starts moving back in the other direction. So when I'm looking right here, there are no dots that got stacked up. Okay, you may have noticed that I decided just to be different. I made my velocity 2 meters per second in the positive direction, and then on the trip in the other direction, it's negative 2 meters per second. I just got tired of doing the 1. Okay, and we've got 6 seconds worth of data. So for the first 3 seconds, it's moving at a velocity of 2 meters per second, and then at time 3, the velocity becomes negative 2. Okay, so these examples have shown us how to go from a motion map to a velocity versus time graph. Now, let's look at the next page where we've been given some position versus time graphs, and we want to make the corresponding velocity versus time graphs. So in the first example, number 5, the object is moving at a constant speed in the positive direction. I know that because it's constant speed because it's linear, and it's in the positive direction because it has a positive slope. The sign of the slope of the position versus time graph tells me the direction of motion. I need to calculate the displacement in order to be able to calculate the velocity. So here, the displacement, you know, is always the final position minus the initial position. Well, the final position was 4, the initial position was 0, so the displacement was 4 meters here. So the velocity is the 4 meters divided by the elapsed time of 4 seconds is 1 meter per second. So this is a situation where an object was going at a constant velocity of 1 meter per second for 4 seconds. And so our velocity versus time graph is a horizontal line at a value of 1 meter per second. Let's look at number 6. Here we have a more interesting kind of trip. The direction changes. First, the object moves in the positive direction. That's this area with the positive slope. And then the object moves in the negative direction. Now, when we do a velocity versus time graph, we're showing the velocity at each point of time, not the average velocity for the entire trip, right? We're showing the velocity at each point in time. So I need to treat these as different parts of the trip because they have different characteristics. In part A of the trip, where it's moving in the positive direction, the displacement is final minus initial. 4 minus 2 is 2 meters. And the velocity for part A was that 2 meters, which was the displacement that was made in the 2 seconds of elapsed time. So the velocity was a positive 1 meter per second. In part B of the trip, the displacement is final minus initial is 0 minus 4, or minus 4 meters, and the velocity of part B is that negative 4 meters that was accomplished in the elapsed time of 2 seconds, so it's negative 2 meters per second. Okay, so here we have a positive velocity for part A. It was 1 meter per second. But then we have a negative velocity, negative 2 meters per second, for the second part of the trip. So again, when you look at a velocity versus time graph, one of the things you need to really pay attention to is the sign of the velocity. When you see something at a positive velocity, for this part of the trip you know it's moving in the positive direction, but then when you see something moving at a negative, at a negative value of velocity, you know it's moving in the negative direction. Okay, and let's look at the final example here, number 7, where we have a trip. Again, there's a little something different happening in 2 parts of this trip. In part A, the object is moving in the positive direction at a fast speed. In part B, it's still moving in the positive direction, but at a slower speed. So in part A, the displacement is final minus initial, 2 minus 0, so it's 2 meters, and the velocity is 2 meters that was accomplished in 1 second, so it's 2 meters per second. In part B of the trip, the displacement is final minus initial, 4 minus 2, or 2 meters. But the velocity is smaller because that 2 meter displacement took 4 seconds to accomplish, and so it's 0.5 meters per second. So when we do the velocity versus time graph, for the first second the velocity is 2, and for the next 4 seconds the velocity is 0.5.